we left off yesterday having finished task 4. So now we have a lot of the Android part of the workshop is really done. Or I mean, a lot of the Android specific sort of screens, navigating between those screens, looking like an Android app, the layout, the themes, that sort of stuff has been figured out. I think some of the difficulty of getting started with Android has to do with like the layout of the file system and how apps are laid out, basically, and all the files that are there. Some of them are mandatory, some are not. And so feel free to ask about that as well. Okay, where in the code base are the connections being made to BDKJNI? Okay, good question. And actually, that's part of what we'll jump in today with task number 5. But to give you a quick answer on this, it's under the app folder. There's a build.gradle.kts file, and in there, it's I'll give you the line number, the exact line number. It's line number 66, where BDKJNI has actually been declared as a dependency. So that's the initial point of entry, and then in the app, the place the class where the Bitcoin dev kit is being used is called the wallet class, and that's the one we'll be building today. So that's cool. We'll be tackling exactly that today. I'm going to take just a bit of time, maybe before we jump right into this. I want to do a little bit like yesterday. We did a bit of like context, history, sort of side questions. I have a few things that I want to discuss. Maybe a few of you were telling me basically that you didn't know about Kotlin. So that's an important part. I didn't really discuss this, and I want to take a minute to address that at least. So Kotlin, for those of you who are not familiar, is a language that it's an open source language that was created, I think, in 2011, and it is led by JetBrains. So it's an open source language, and JetBrains has created sort of a nonprofit organization that supports it, and they have one seat at that table, but they're the big company behind the language, so they put a lot of the money and the development behind it. But there's also community-led, certainly PRs, and like the discussions are definitely open to anyone for the language direction and how it's being developed. So that's the basis of it, is 2011 JetBrains. JetBrains is the company that creates the IDEs for Java, the IntelliJ, and Android Studio is developed by Google, but it's based on IntelliJ. So JetBrains had the incentive to create a language basically that would drive the sales for IDEs, and that's how they sort of got started with it. And nowadays, Kotlin was invented as sort of like a successor to Java, you could say. I think a lot of people consider it the evolution of Java. I don't want to offend anyone, and we're on video here, so there's a lot of great Java code out there, and like, people love the language they use, but Kotlin is often seen as this sort of like successor to Java, and I think for very good reasons. So if you're familiar with Java is still taught in school a lot. I think you're gonna absolutely love Kotlin. So, and Kotlin has visions that are very, very broad. I think it's a language that will continue to gain momentum and steal market share from all other languages. So, but the general idea for Kotlin is it targets you write Kotlin and you can target three main sort of like different directions you can go to. And the first one, and we're going to tackle Addie's, actually, no, sorry. I thought React, but I see now React Native. The first one you do, the first target you can use for Kotlin is JS. So you can actually compile Kotlin into TypeScript, and it's interoperable with your NPM dependencies. So you can actually write JavaScript in Kotlin. This is not something I have worked with a lot, and I think it's like some of the early, it's really usable and everything. I've seen a lot of demos and I've done the basics myself, but it's not like the main target for Kotlin, but it's also targeting WebAssembly. So again, I think Kotlin is trying to get at the web in this sense, and especially with the JS, I think the whole like is JS is only losing ground right now at this point to everybody else who's doing better and faster, including TypeScript, right? Which is sort of JS, but everybody's sort of realizing that type safety turns out to be really useful. So everybody's moving really to TypeScript. That's happening really quickly. And so idea of other languages that are also compiling, or I think in this case, it's called transpiling to JS is a really powerful idea, and Kotlin is doing just that. One of the few languages that does that. So that's one. The other target is a JVM. The JVM target for Kotlin is the most powerful of them. It's the most developed one. It's the one that started it all. The JVM target is the one that is being used in the case of Android. So Android used to be Java, and you can still develop apps in Java for the Android platform because it runs a form of the JVM. But I think it was in 2017 that Google announced at Google I/O, which is like the big Google conference, they announced support for Kotlin as a first-class language for Android. And then the next year, they made Kotlin the sort of like the preferred way to develop Android apps. And I think since then, it's over 50, 60% of apps that are developed in Kotlin for very good reasons. So I think Android also is moving towards Kotlin really, really heavy on the Kotlin side of things. All the docs, for example, are now in Kotlin by default, that sort of thing. So that's the other target is JVM. And then the third target is newer. It's like the past 3 years, I think they've been working at developing a native target. So you can also take Kotlin and compile it to native machine code. So you can target architectures and write native code. So you could, for example, write for embedded devices that don't have a JVM on them. So it's not the speed right now for the target for Kotlin Native is certainly not as fast as C, C++, and Rust. So that's another thing because the memory model is different, but it is compiling to native. And so that allows you a range of new things that are really cool that the JVM has problems with, right? Because of the garbage collector, because of you basically have to have a JVM with you if you want to run JVM applications. So Kotlin Native is a cool thing. And this is where Kotlin Native is coming into play with Adi's question with the thoughts on Kotlin versus React Native. Kotlin Native is interoperable with iOS devices. And that part of Kotlin Native that you want to use on Kotlin on iOS devices is called Kotlin Multi-Platform Native. So Kotlin Mobile Multi-Platform, sorry, KMM, but it's an offshoot of Kotlin Native. And what it does is it allows you to compile to machine code. So you target an architecture and you can run your code from there. And so KMM is taking a big shot at this sort of market of creating one code base for two apps. And the idea is to create a code base that runs the whole like back end, if you will, of an Android app or sorry, of a mobile app, the whole like structure, database, the whole back end basically. And on top of that, you create a native experience using, the language for the platform. And so KMM can be used to create common code that you're going to use on iOS and on Android. And then on top of that, you add a very thin layer of pure Kotlin, like Jetpack Compose, that would be like your UI directly on top of it for Android, and then a Swift one for iOS. And so that's becoming more and more popular. There's a ton of apps that are using that right now. If you've used Phoenix Wallet in the Bitcoin ecosystem, Phoenix Wallet is actually migrating to that. So Kotlin multi-platform. So that's one way. Versus React Native. React Native, for me, will always be a second-class solution. It feels like you're not writing a native application. And in general, when you want to go deep into it, you end up having to write native code no matter what. And so that's actually a plus of React Native. It's not a dunk on them, because React Native allows you to go and write actual Kotlin code. But what you find is that a lot of React Native apps that are like, the basics are fine with just React. But if you want to start playing into optimization, or you have a lot of like your app is getting slow, or you want to play into things like Bitcoin, for example, then most apps end up having to write native code anyway. And so they have sort of a React Native shell outer or top part, right? Again, the UI, which will work on iOS and Android. But then as soon as you get into complexities, you have to go and write native code. And so you end up having two apps anyway. Your iOS has to write some Swift, and your Android has to write some Kotlin. So that's sort of my idea there. But of course, I'm an Android dev, so for me, like, that's my main focus. And Flutter is kind of cool. That's what I'm going to say about it. I think it's okay. You can target the web, you can target Linux desktop, so I think that's cool too. But again, I think Kotlin multi-platform is coming in to take the win on this, and it's going to displace Flutter also. It's going to continue to take a big share of that. So that's sort of what I had to say about Kotlin. Does that help out a little bit? I think Kotlin, a lot of people, the main question is Kotlin versus Java, because they're both targeting the JVM. And I think that Kotlin in general has a much broader perspective and is trying to achieve much more than just like the JVM. So in that sense, it's quite a bit more. And the other thing, the reason why people love Kotlin, and I want to just take a second to speak of those, if you think of like the newer, more modern languages that are very, very loved, right? So the languages that came in, that arrive in 2010, 11, 12, usually you'll be thinking of 4 languages. You'll be thinking of Rust, which is 2011 or 2010, then Kotlin, then Go, 2009, sorry, and Swift. So those 4 languages sort of arrived at the same time, 2010, about a decade ago, and are all like very, very loved. And they're modern. They bring new ways, a lot of the paradigms are like included in them by default. Lots of much less boilerplate code, this sort of thing. And Kotlin is one of those 4 basically that's arrived and is newer. One of the reasons why it's really loved compared to Java, I think, and I don't want to, Java's a great language as well, but what I'm trying to say is I think that Java came in, you have to understand what Java was trying to do. Java is from 1995, and when it arrived on the scene, the big players were C and C++. That's what you wrote if you wanted to write fast code. And the problem with those languages is that, again, we talked yesterday about memory leaks, and you had to manage memory manually. And that's a huge hassle. It's very, very hard to do correctly, right? Everybody can learn the basics, but to do it well is very, very hard. So Java came in 1995, and what they said was, we're going to manage memory for you, and we're going to be almost as fast as C++. And they did a really, really good job at that. Like the JVM is an unbelievably just well-oiled machine. And it's important to separate the JVM and Java itself, right? Java targets the JVM, and then you can run bytecode, Java bytecode on the JVM, but you don't need to write it in Java. You can write it in Kotlin, you can write it in Scala, you can write it in Groovy. There's a bunch of languages that actually target the JVM. And then from that JVM, you run it everywhere, and it's really, really fast. So the JVM, for example, is easily 10 times the speed of like the Python virtual machine, or the Node.js, virtual machine, that kind of stuff. So don't quote me on that. Is it 10? I don't know. But it's by far the fastest of all the virtual machines. But what Java came in, Java made 3 promises. They arrived on the scene. They said, we're gonna promise you 3 things. First of all, let me just check this. Okay, so first of all, they're gonna say, we're gonna be almost as fast as C and C++. Second, you're going to write one, you're going to run everywhere. That was the other promise. The idea that you had this virtual machine that you could install on all the machines, and you could write one time your Java code and it would run on all these architectures, was really powerful. And then third, we're going to be backwards compatible forever. They promised that. They said, you're going to run 20 years from now, you're going to be able to run on the JVM code that's written this year. Like in 1996, if you try to run this code in 2020, it'll run. So those were the three promises. The first two were really well executed. But the third one, this sort of backwards compatibility forever, turned out to be a really, really big problem for Java. And that's sort of where Kotlin came in to swoop in and bring in new stuff. The backwards compatibility forever forced them to keep with like design decisions that were maybe outdated at some point, right? Language design evolve. It's a very fast moving field. And so when it was time to bring in new things, deprecate older stuff, they couldn't. And I think that over time that's been one of the things that's plagued the Java language. And then Kotlin arrived with like a new take on a lot of these things. And nowadays, things like null safety, there's really, really big stuff that you would expect almost by default, but that Java wasn't able to implement outright. And so, but I think they're making a comeback right now. So they've changed the release cadence and things are looking good for Java as well. But I'm a fanboy of Kotlin, so yeah. I hope that answers some of the questions. I've spent maybe 15 minutes on this. If you weren't convinced before that Kotlin was a great language to learn, for the application level, like this is the way to go. It's a really beautiful way to develop applications. And even for desktop, right now we're getting Jetpack Compose. So we talked about Jetpack Compose for Android yesterday. JetBrains is bringing that same sort of like library way to develop apps for the desktop. And we're using it on Kotlin Native. So you can compile for native architectures and build applications, desktop applications directly for Windows, Linux, or Mac. And you can use Jetpack Compose to do it. So this is new. It's not even it hasn't been released 1.0, but it's a really cool way to build applications. And I think it'll continue to gain momentum. So that's what I had to say about that. Here we go. I'm going to share my screen and I want to show you some of the comments I got is we want to see more tools. Like you came up with, I gave you a bunch of links. I showed a bunch of things. And I think I didn't realize necessarily that when it's your first week in Bitcoin or your first month in Bitcoin, a lot of these tools are brand new for you. So I got a few more that I want to show you, like, the block explorers and, some tools like that. So let me share my screen and I want to show one more important tool I think that you'll be using, especially for today. Oh, I had pulled out the Stack Overflow. If you're not familiar with the Stack Overflow surveys on for developers, they have a question about the most loved, dreaded, and wanted languages. And it's always fun to see. And Rust is one that battle for the past, I think this is the 5th year in a row, 2020, or the 4th year in a row that Rust wins the most loved language. And at the top, you find all these very more modern languages, like, Kotlin is here at number 4. TypeScript, again, is pretty brand new. And if you look at the 2020 version of that, again, Rust is just taking the crown again. And then Kotlin number 4, and you have Go, and, so Swift is here as well. So we're going to work with output descriptors today, right? And I want to show you this this tool. It's a lot of people use it. It's good for like testing your ideas, or when you have addresses that don't match what you think they should be matching, or paths, right? You're working with BIP 39, BIP 32 wallets. You want to know how they work. This is Ian Coleman's tool. I want to show you this. So we had yesterday my CLI. In my CLI, we created this wallet, and I can use the CLI to generate these mnemonic words for me with an expriv. And that's what we did. So I'm going to take these 12 words and I can put them in here, choose generate 12 words, and then from there, change the type of coin. And we're going to grab Bitcoin testnet. And out of this comes out of tpriv 8ZGXM, whatnot. And you find that it's actually, indeed, it's the same. I had not tested this before, but I knew it was going to work, right? So it's the same tpriv as what I have. And so that's give me immediately that gives me an idea that like things are working pretty well. And then I get a choice for like derivation paths, and those are I'll touch on this maybe in a minute, but I think you might have discussed this in the first week with Callie. So typical wallet right now for this workshop, what we're doing is we're deriving BIP84 compatible wallets. And you can see that the derivation paths are listed here. I can actually change it. I could, account number 2 if I wanted to. And coin is number 1, right? We're using testnet, so that coin number is number 1. And then I get immediately a number of addresses. And you'll find that if you go back in your wallet from the CLI yesterday and you do get new address, this is the first address it'll get you, is that exact one there, the ADD whatever, and then SQK. So this is super useful, and you can export them in CSV format. You can play around. Sometimes you're not finding what you're looking for. You play around with this, and it really helps. And when we talk about BIP 44, 49, 84, I think that we go over those really quickly. But if you're not sure about them, I have a blog article I wrote a while back that I want to just mention it. And it's basically a wrap up of all those BIPs that you hear about that are really important for building wallets. So when you're building a wallet and people say, what's the derivation path? And especially for output descriptors, you're going to see those a lot. You want to know how they work and what they do. This is sort of a reminder, and I have a bunch of graphics there. So, and I think one of the important one is what we talked about yesterday. You're being given this expriv, and this master node. What do you do with it, right? You need to decide where to go from there. And there are predetermined, agreed upon ways to derive addresses. And those are defined in those BIPs. And this is how we basically decide how to define them. And what we're doing today, if you look at my graph here, what we're doing today is deriving a BIP84. So those will be Betch 32 addresses. And so we'll be starting from our tpriv, which the CLI will give us, right? Or in our case, I'm going to get the Android app to generate it for me. So that's my M. So that's my starting point. And from there, I'm going to derive at a specific branch of that tree, and we're going to get to the addresses. And the way we're going to do this is by saying, I'm going to go to 84. So I'm declaring basically that I'm using BIP84 as my system to derive my addresses. And then my coin type is going to be 1 because we're doing testnet. And then we're going into account numbers, and I'm going to choose the first account there, which is always 0. And then we are going to generate both a receive address and a change address output descriptor. So the 0 and the 1 will be used. And then from there, we get the indices. 1, 0, 1, 2, 3, whatever. So feel free to go back to that kind of thing if you're not sure about the whole like deriving wallets and output descriptors. So one last thing I want to talk about just before we get into the wallet is the idea that you have a whole summer in front of you, and even the whole week if you want to keep working on the wallet. Like if you say, well, this week I'm going to focus on this wallet, for example, or Android. And I want to, before we dig too deep into it, I want to tell you about some of the things that you could be looking at implementing, some of the things that the wallet is not implementing. So as we're going through the code base and you're thinking through this, think about these other things that are not in the wallet, and maybe this is something you want to implement yourself, or if you're forking this and trying to fix things or make it better, these are examples of things that you might want to add. So for example, I'm hard coding the derivation path. So I'm using a BIP84 standard wallet. If you wanted to derive a different type of wallet, so let's say a 44 or 49 BIP, then that's not possible right now with the wallet. So the wallet will always generate a BIP44 compatible wallet. If you wanted to generate a 49 or a 44, you'd have to offer that option to the user and then go and derive the output descriptors based on that. So it's actually a really easy change in the string, but you'd need to sort of like offer that option and have a toggle or something. So that's one thing that could definitely be added to it. Another thing is that we talked about Electrum servers yesterday, right? So Electrum servers are really important, and we talked about the trade-offs. And at this point, we're using testnets. So a lot of the attacks that could be performed against you basically are not really, they don't matter too much if you don't receive your payment or whatnot. And we're using a very famous server. So we're using Blockstream's Electrum server. So there's not a lot of problem there. And the privacy problems are not coming through as much with testnet, but it's still missing out of the wallet. In theory, you don't really want to force the Electrum server on our user. We'd love to give them the option to choose which Electrum server they want to connect to, particularly if they have a node at home, right? It's a very common use case. A lot of people will have nodes at home and they have an Onion address. They want to connect to their own Electrum servers. So that's not being offered right now. And I think that'd be a great addition to the wallet. So consider doing that if you're interested in Android apps and you want to work on this for the rest of the week. Another thing that could be done definitely is cleaning up the UI. There's a lot of little things that need to be added from a design perspective. So if you enjoy like design, you want to take a look at the Bitcoin design guide that we discussed today. I hope I gave the link. I'll put it in the chat again if you're not sure where it is, but just going through and matching against the wallet, you'll find a lot of like missing pieces that you might want to integrate. So that's another cool thing that could happen. And what else do I have? You'll see that the transaction history UI is very, very basic. So we're receiving the transactions and we're just listing them. I think that could use a rewrite and a cleanup of the UI, definitely, if that's something you're interested in. And lastly, the wallet doesn't have a PIN. So when you fire up the app, it automatically opens. So it goes right into the wallet, and somebody who uses the phone could like spend the funds immediately. So maybe adding a pin there could be cool. So I got a ton more ideas too, obviously. So let me know if you want more ideas on what to do better about this app. But those are just like some ideas. So as we go through the code base, try to think of some of these things too.